Hi, everyone. Welcome to the third webinar for the Open IoT Challenge participants. I'm here with Bor from Contact Software, who's going to tell us a little bit more about their company and what they do with IoT. Bor?
Hi. Thanks, Roxanne, for the introduction. Yeah, as Roxanne said, I'm going to tell you a little bit about my company, but just some details about me. My name is Bor Gonzalez-Usac. I come from Spain, and as you can imagine, I work for Contact Software, not that long, just about a year. And I'm a core developer in the IoT solutions that Contact is producing. So now we'll start sharing with you my slides. Let's see if I get it right. So you should be seeing something now.
Yeah.
All right. Okay, so yeah, just also wanted to say if you have any questions, just write them down, and at the end of the presentation, I can answer them. Okay, let's get started. First of all, Contact Software was founded in 1990, which means that we are like over 55-year-old. The company is mostly focused on software to manage the product life cycle, or as it's usually called, the PLM. More to this topic in a minute. We have more than 200 employees from several countries and many disciplines. I myself am, for example, not software engineer, but a mechanical engineer. And we are mostly based in Bremen, Germany. Many other locations here in Germany as well, and Switzerland and Austria as well. And yeah, I also would like to say that we are a pretty international oriented company. We have customers and partners throughout the world. So I would like to talk a little bit more about the aforementioned PLM business. PLM stands for Product Lifecycle Management, and it is, in a nutshell, the management of the whole process from a product idea to its production. And the SIM database, which you can see on the top left of the screen, is the name of the product that our company is selling to manage the PLM requirements. It basically lets you take control of the necessary in a centralized manner, as you can see here on the slide. It's an information hub for requirements gathering, development of models, mostly mechanical 3D models done in CATIA, AutoCAD, this kind of CAD systems. Also, it's a platform for gathering quality checks and validating the models. You can as well generate a bill of materials when the product is ready to be produced or manufactured. And as well, there are possibilities to handle configuration management, which is like variations on the same product. Say, like, for example, a car can have different motors, different colors, and this is something that we are good at as well. And of course, the documentation of the whole process. Yes, our key customers are in the automotive and transport industry, and as well in the mechanical engineering and plant construction industry, each of which accounts for about 35% of our share revenues. Other important industries are high-tech, medical engineering, and consumer goods. And we have some customers that actually infrastructure providers, like the Deutsche Bahn, which is the German railway system here in Germany. So let's go back for a second to the PLM concept, and so to say, let's try to push it a little bit further and think, what if we start managing the product even after production, not everything before production? Or in other words, what if we start managing real-world data as telemetry for machines or maintenance record, like lifetime of a given product? This is where IoT should start ringing a bell. And yeah, managing real-world data let us, first of all, profit from all the classical IoT advantages like typical condition monitoring, predictive maintenance, or just something simple as the documentation of real-life usage of given components, which is useful for reusing or recycle these given components. And now the interesting part. We can, with the help of this data, extract new insights, like, I don't know, for example, one could be that this given type of machine, when working at high altitude and using a given lubricant, lasts less than expected. This is some kind of relation or insight that you cannot normally do if you are not gathering huge amounts of data and processing them. And this is extremely useful for the engineers that have developed the product. So this is where the bridge between PLM and IoT becomes really, really powerful. We are able to give feedback to the design process and therefore improve the product, and that's the customer satisfaction. And yeah, here a short schema or list of the topics our product also wants to address, which is managing the digital master and digital twins, handling device registrations, which could be handling all the machines that are connected to our system. We also are addressing the software management, for example, in order to deploy updates or know very precisely what kind of software are using our devices, or in other words, what version. Also, we want to provide a community platform so that different customers of the same product can share knowledge and produce different, I don't know how to say, like different connections between them that could allow them to have better feedback for engineering. And also, yeah, provide some platform for analytics. So yeah, more or less, this is our value proposition in the IoT business. And this takes form as the product contact elements for IoT, as you can see there in the left top of the slide. Here are just some examples of real-world scenarios that we are working in. The first one on the left, it's Femobile. This is a Belgian producer of trailers. And in this scenario, we are monitoring the condition of the braking system. And on the right side, it's Hamburger Hochbahn. And in this scenario, we're monitoring some parts of the train, for example, the automatic doors. Okay, nice, right? But if I were you, I would be wondering, cool, but what does it have to do with the Open IoT Challenge? How can I use any of this for my projects? And well, as many of you may have guessed, this product that we are offering is not open source. It's standard enterprise software and therefore requires paying licenses. So the answer to how can I use it for my IoT challenge project is, well, I'm sorry, I think you cannot. But before you start thinking this has been a waste of time, let's jump to the next point. As I said, we can offer our products to you. It's just not possible, but still we would like to share some of the ingredients that our products are using, which may help or inspire you for the Eclipse IoT Challenge, or maybe, who knows, for future projects that you may be developing. Yeah, at its core, we are Python nerds, or as some people like to say, we are Python evangelists. And that's because we truly believe that Python is an excellent language for first prototyping, but also for building real-world products. It is easy, it's concise, and you can be pretty productive when using it just by itself. And I would say exactly as important, it's also like a gateway or a door to a huge ecosystem, part of which is really, really good for building IoT solutions. This results in you not having to write like 10,000 lines of Java or whatever language you could be using to get something some IoT solution up and running, you can do it with Python very easily and in a very pleasant way. For example, you have plenty of Python libraries to gather direct sensor data. In case you are, for example, working with a Raspberry Pi, it's just very, very easy to gather temperature or sensor data points. It's no big deal. Plenty of libraries for that. And when it comes to moving the data through the network, you have more options than you actually need. Here, I brought the 4 ones that I like the most. And when it comes to making sense of this data that you have gathered from your devices, there's like a universe there. And it's huge, more than you can need, than any kind of need that you would have. You can most probably carry it out with Python. It's even, in many scenarios, it's actually taking the place of MATLAB and other enterprise software. So in other words, when it comes to data crunching, Python is not at all the wrong option. It's a clear winner. And of course, all of this is free open source and pretty easy to work with. Yeah, and just to give you a gist of how easy it can be, I just thought of a simple example in which you would have a device on the field that could measure, let's say, temperature. You would like to gather data from its sensors and then send it over MQTT to a given backend, let's say. For this purpose, we can use just some Python libraries, which could be, first of all, Unite. It's an Eclipse project that aims for the standard protocol for telemetry transfer. By the way, we Contact are actively collaborating in this project, so if anybody wants to use it, maybe you will get some extra points. And then there is Paho, which is an Eclipse project as well. And it's, yeah, very nice and simple, easy to use MQTT client. So yeah, we can just skim through the code. Here on the left side would be the code that could be deployed in the device. We have like 7 lines. The first 2 is just importing some libraries, our libraries, then generating a MQTT client and connecting to the broker. Then these 2 lines over here are actually generating the message that we want to say. We want to send, sorry. Let's say that we have a device with the ID 001, and the telemetry we are sending is just a temperature value. And then finally, we just publish it. So 7 lines of code, and you have actually sent some telemetry data over the network. And here on the right side, we can see what kind of code would receive this message that we have sent. Here, we import the 2 libraries as well. We define some event handlers here on connect and message that will be called when the MQTT client connects to the broker and when the MQTT client receives a message. We just bind them together with the client object, connect to the broker, and start listening to messages. And then when a message from this side arrives, it will jump into this event handler, and we can just decode it by using the Unite library. Then suddenly you have a nice, easy, clean object that you can use for whatever your purposes are. Yeah, I think this is pretty sweet and easy. So you might think that was just a toy scenario, but these concepts that I showed you are pretty much what powers more complex scenarios. Like, for example, this is a real scenario that we have integrated into the IoT Eclipse testbed that consists of a real world machine. In this case, it's a grinding machine, which is being monitored with acceleration sensors just to measure the vibration. And as you saw in the previous example, it's packed together into a unite message and sent with requests to a gateway. This gateway implements a web service with the help of MorePath here. Also a pretty easy library to use. Receive the message, as I said, then understands it because it's unite, it's the standard format. You don't have to think too much to pick information out of it. Then we pass it to some machine learning techniques implemented with scikit-learn. And out of these machine learning processes, we get to know if this telemetry data represents a good condition of the machine or not. Or in other words, we get a result. We get to know if the machine is okay, if it's gonna need some kind of maintenance soon, or if it's totally broken right now. Good, and once we have the results, we can pass it to requests again, or we can use requests, better said, to send it to our backend, where we store this data and represent it. Good, so that would be the concept. By the way, you can see code that simulates this scenario in the repository for the IoT Eclipse testbed this year. And we will just somehow make it available to you. You don't have to copy it from here directly. And now, if the gods of the demos allows me, I will try to show how this works with real code. Okay. So, first of all, we will just fire up the gateway. This is the code that starts it. And this URL here is the URL that will receive the messages, the results that we have extracted from the machine learning technique. So we just start it. Okay, there it goes, it's running. And then let's go to the machine itself, or to the device that is attached to the machine, and send some messages to the gateway. Just as a short example, I think it's nice if you get to see how unite messages look like. So I'm gonna show you a very small message. It's just plain JSON, and it's also mostly self-describing. Okay, so back to the scenario. Let's actually send some data to the gateway. Okay. And now what has happened is that from here we have sent a PPNP message or unite message to the gateway. And the gateway has received it, processed it, and passed it to the contact elements for IoT backend. And now we will go to the dashboard of the IoT backend. Let's see if this works. There you go. And this is how it actually looks like. This telemetry data here is what we have sent now. And yeah, I think with this you can get the gist of it. This is only the telemetry data here, and our dashboard includes many more things, like, for example, the bill of materials of the machine, some 3D model for you to play around, and also some kind of community part to it, where people can communicate on the context of this machine. So this is pretty much it. And yeah, first of all, thank you for your attention. And if there is any question, I'm more than happy to answer them.
There's actually one question. One
Yes.
of the participants is wondering, so this is more Industry 4.0, and does it differ a lot from traditional IoT code or use cases, and how can you merge the two?
Wow, that's a pretty
Yes.
abstract question.
So I was saying that Industry 4.0 is doing a lot of IoT now.
Yeah, this is of course a scenario of Industry 4.0, but the core concepts that we are using are from the more traditional or more simple IoT scenarios.
Okay, so that's why it's called Elements for IoT, because you use the IoT elements to do this Industry 4.0 stuff.
Exactly.
Okay, perfect. So that answers the question. And that's all the questions we have. So viewers, if you have more questions, don't hesitate. You can put them in the comments and we'll forward them to Bor and he can answer them for you. So thanks,
All right.
Bor.